Hey there everyone, my name is Ryan Schul. Welcome to my channel. So today I want to take a look at different things that we can do with Python Pandas, and we're going to look at basically 30 different categories. So I think these are 30 things that you're going to encounter very quickly in your Pandas journey. Okay, now this is not completely exhaustive and comprehensive, right? But I think these are 30 things that you will probably come across very quickly if you haven't already done so. Now, I understand if you talk to 30 different people, you'll probably get 30 different lists, but I think this is pretty on point with the types of things you'll normally see, whether you're new to data science or machine learning or even deep learning or just basic Python programming. If you're just doing generalist types of things, I think you're going to stumble upon these 30 topics sooner or later, probably sooner rather than later. So why would we even take a look at this, understand core operations, right? Syntax, categories, different ways of manipulating data, right? I'll show you how to do pivots, unpivots, melting, stacking, things like this, aggregations. So you're going to run into this, I guarantee it. You might as well, get used to it and get ahead of the curve while you can. Let me make a couple little housekeeping adjustments over here. I like these symbols. I like the way these things look. I should use this all the time. Okay, so that's it. If you look at the major big categories, there's probably a few dozen. If you look at the number of common patterns that you'll see in your work, pretty darn quickly, if you immerse yourself in Python and Pandas work, probably hundreds. And if you talk about the different number of meaningful actual events or combinations of tasks that you can do, it's probably on the order of thousands, right? But eventually you'll start to see the same patterns over and over. And when you get to that point, then you know that you have come full circle and you've seen pretty much everything. I'm still learning new things almost on a daily basis, but the things I'm going to show you, I have seen ad nauseum over and over and over. So these things are pretty common. Okay, we're going to look at loading data into Pandas. So reading CSVs, Excel files, things like that. We're going to look at shaping. How do we create shapes? How do we do aggregations? How do we do things like slicing? How do we slice the data frame into different pieces or different parts? We're going to look at aggregations, changing data types, filtering, masking, location, ilocation query, which is similar to what you would see in SQL or things like this. We'll get into that just a little bit. Merges and joins. We'll get into this just a little bit, and aggregation and reshaping. Okay, so things like calculating a sum, a mean, min, max, counting items. And by the way, between those 5 things, that probably covers almost everything that you'll see in Pandas, whether it's a sum, a mean, which is an average, a count, a min, or a max. It covers most of the things. Now, there are thousands of things you can do beyond those 5, but in my experience, and I've been doing this for a little over 20 years, those 5 things come up all the time. The other things, you don't really see that much, guys, to be honest. So if you don't know it, that's fine. If you know it, that's great. If you don't know it, Google it or use ChatGPT to figure it out. But those 5, summing, counting, mean, which is the average, min or max is what you see over and over. Sometimes there's a standard deviation. Sometimes there's different quartiles. We'll look at an example of that, but some of these things are somewhat rare. You don't see it on a regular basis. Okay, so I think that is a good setup here. Let me check something really quick. All right, I'm pretty pumped about this one, guys. So let's just jump into it. So below I have a couple of data frames that I'm creating, and this is going to represent a few different types of things that you'll probably see early in your career, or if you've been working with Python for a while and Pandas for at least a little while, you've probably stumbled across this at this point. So I want to go ahead and use my main libraries right here, NumPy for numerical analysis and Pandas for, of course, Pandas data frames. I'm going to set a display max call width. The max is going to be none. This is for no ellipses. So if you see a very wide column or a column that has lots and lots of text in it, a lot of times this will get caught off unless you specify that you want to see the maximum call width and set this to none. Maximum columns will show all the maximum columns or show all the columns in the data frame. If you have a larger data frame, I forget what the cutoff is, maybe 15 to 18 or so columns. I think by 20 columns they're cut off, so you'll see the first several columns, the last several columns, but you'll have these ellipses, which is the 3 dots in between unless you set this, right? With maximum rows, we can see all the maximum rows in the entire data frame. If you don't do that, then you'll see the top portion and the bottom portion. I think it's 5 and 5, 5 on the head and 5 on the tail. So I'm just going to set those just so we can see everything. Okay. You know, they're saying if you see something, say something, right? So kind of like that, not really, but anyways. So we have customers over here, products over here, and orders over here. So I'm going to go ahead and create the data frame. Now this is just fictitious data, but it's going to serve the purpose of these 30 major categories I want to introduce you to, so we can get the layout of the land for all of this pandas stuff, right? So I think these 3 data frames will suffice. I tested this last night. It seemed to work pretty well. Now, of course, you can import the data from a bunch of different sources. That's actually the first example we're going to see, but I'm not going to do that in this case. I'm just going to create my own. This is called synthetic data, and I do this for some of my videos. It's actually pretty easy to do this, and then you don't have to go hunt and peck around for all different data sources, and then you have to merge them together, right? And if one data source doesn't match another, it's not going to merge. If you're trying to concatenate different data sets together and they don't match up, that's not going to work too, right? So I just set some that I know meets the criteria that I want to work with here, and I can execute pretty smoothly, right? If I have to go, again, if I have to go hunting around for all these things, it's going to take a lot longer. This is just easier for me. And again, it's pretty realistic, guys. So you're going to see these kinds of patterns over and over. So I think that is... it's a nice intro. Okay, so this is what I'm looking at the beginning here. So I have a few different data frames, right? You can see over here I have customers, I have products, I have orders. I'm going to display this. This is the web March. Okay, I'm just looking at one. Let me look at some of these others too. Customers, products, and orders. Okay, so yeah, let's look at the customer. Okay, look at the head by default. We'll get 5 rows, products and orders, right? Row and orders, is that it? Yeah, I think so. Okay, so those look fine. I'm going to put something between too, just to break it up, just to break up the monotony here and make it just a little bit easier to read. Print, I'm going to print some lines times 80 multiply by 80. That's going to give me 80 lines over and over. That way I don't have to do one of these guys, right? Oops, not that. It was a space bar. I hit the wrong thing. I'll have to do one of these guys. All right, that would be the alternative. If you just want to write 1 and multiply by 80, it's basically the same thing. Okay, so just breaking these things up into different sections. That's all that does. So I think that looks nice. It's just less typing for me. Okay, so that works out pretty well. Okay, so we have our major data frames over here. This is what it looks like. Customers, products, and orders. Change the format just a little bit. It doesn't even change anything really. Okay, so that's what we're going to start with. So the first 5 things I want to show you right here, I'm not even going to demo this. I have this in a lot of my other videos on my channel, so you can check out those others. I'll give you the code. I'm not going to actually import anything, but these first 5 that you see over and over and over, and unless you're creating your data set synthetically, like I just demoed just a moment ago, you will have to do this. Now you can get it from the web, you can get it from a CSV, from an XLSX file, from a JSON file, from an XML file, select from orders, from a database, right? So here are the first 4 probably most common ways of extracting data or fetching data from a source to a destination, which is going to be a Pandas data frame. Okay, so you read it from the CSV file into a Pandas data frame. So read CSV, Pandas read Excel, and then Pandas read JSON. Again, you can do this with XML. You can go to a website and fetch data that is on a table from hosted on some kind of URL or HTTP address and pull that into Pandas and work with it that way. You can have output of data to a CSV, right? So you can go ahead and do your imports over here. Here are 4 very common types of imports. Again, reading from CSV, from Excel, from JSON, selecting from a database. I have examples of all of these things on my channel. You can check those out. Once you do the analysis, manipulate the data, and you're ready to save it, to export, save for future use, to share with some stakeholders, to go ahead and create some reports. Maybe you have to email it. Maybe you have to, I don't know, teach a course on it like I'm doing right here, right now. Maybe you have to do that. So if you want to get your data frame from Pandas or from the Python environment out to a CSV. It's the name of the data frame to CSV. And you go ahead and save it like this. This will go to the default path. If you don't have a path to your desktops or some kind of network drive where you want to save this, just goes to the default wherever you installed, and the concat, that's where it's going to go to, right? So if you don't point it someplace, it just goes to the default. And if you want to save this as a Parquet file, okay, so this would be the name of the data frame. This is the assumption here, at least. And you go to Parquet, and this is saved as a Parquet file. So I don't work with these too much, but I believe you can read the headers of a Parquet and understand everything that is in the file, so you don't have to load the entire thing. And these things can be massive, on the order of, I don't even know, gigs and gigs, hundreds of gigs, thousands of gigs, large, so pretty large files, right? But my understanding is that they open very fast and they close very fast, and then you can sort of see the schema of the file, I believe, very quickly, so you don't have to ingest the whole thing, right? If this thing is 1,000 gigabytes or maybe 10,000 gigabytes, right? These things can get pretty large. That would be a very efficient way to work with a massive data set. So Parquet is something that I think is getting pretty popular. Again, I've only touched on this just a tiny bit years ago, but that was my understanding of it, right? So reading large files, if you need to do that, that would be the data type or data structure, whatever it's called, the data type that you're working with, I believe. So let's look at the next 5 things over here. So the first 5 was reading, and then 1 was exporting, right? Writing, reading, and writing. Reading being 4, and writing out to a file, that would be number 5. So 6 through 10, I have inspect and understand. So obviously after you ingest the data or fetch it from some source, like I just described, then you have to do some type of analysis, right? So inspecting, understanding the data, reporting on it, maybe cleaning, aggregating, right? Running sums, counts, averages, looking for those means and those maxes and things like that. So you have to understand what the data looks like and what it consists of. Let me hit Control Enter to run this. So here I have customers.head with a new line break over here, customers.info, then customers.describe, value counts, and then I'm looking for missing values. So I'm going to have a is_sum or is_na.sum, and then is_na.sum.sum. Okay, so we'll see how these things work. Okay, so the first example right here is looking at the head of a data frame. Right here we have 2 rows. If this isn't specified, it defaults to 5. So here's the first 5 rows, right? This is what it looks like, and we'll have 0 through 4. So Python is always 0 based. So it starts with 0. This is actually 1. Like if you had this in Excel, this would be row 1. In Python world, it starts with a 0, not a 1. But these are the first 5 rows. So this is the info over here. So you get the column name and then any kind of nulls. There's no nulls in this data, so that's good. So everything looks fine over there. And we have the data type. So this is integer, right? This customer ID is actually an integer and not an object or a string. So if we want to do joins or concatenation or merging on that, then we can do that very easily with an integer type of data type. And these others, the other 3 over here are objects, and then we have a datetime, and then we have one more object. So it's object, which is a string. These are the same things as string. This is a date, and then this is another string or object. So if we want describe, this is giving us basic statistics on the file. So we have a count with 60 records, mean, which is average over here, standard deviation is 5.3, min max 50th percentile, 75th, and then max over here. Okay, so it looks good. Value counts. So we're looking at the loyalty tier, bronze, silver, and gold. So we have 12 bronze, 6 silver, and 2 gold. If we get back over here, the value count comes from over here. So you look at the data frame and then the field that you're interested in and do dot value counts. So that's the property right there. And this new line will just return to the next line. Okay, so we can count all the unique items over there. And again, we get 12, 6, and 2. And then missing is an A. So here we see 0, 0. Then we see 60 missing values. So paid amount. So in 60 cases here, we have no paid amounts filled in. That doesn't sound too good at all. But that's fine. Okay, that's fine. And then payment method, missing 0, and paid TS is 0. Okay, so we can see over here, this is giving isNA.sum missing values per column. So we can see 2 columns have no missing values right there. This one has 60 missing, and then these two have none missing. If you do isNA.sum.sum, it takes everything and aggregates all the missing values into one aggregate count. And in this case, it's 60 because we have 60 in this column. This is 0, this is 0, this is 0, this is 0. If we had 1 missing down here, the isNA.sum.sum would be 61. So it takes everything for the entire universe that you're working in and does the isNA counts for the whole universe on one line. Over here, it breaks out onto different lines depending on which field you're in, or depending on which feature of the data frame or column, right? A column, a feature, and a field are all the same thing. So let's look at some cleaning and transforming. So I set this as teaching points 11 through 19. So we got through the first 10. We're going up to 30. Okay, so Control Enter to run the cell. So let's intentionally inject some missing values. I have PD short for pandas, NAT and NAN. These are not numbers, okay? And I am going to put this into, let's see, into this field right here, sign up date and payment method. And I'm going to have just some missing values over here, okay? So sign up date right here is missing, and paid amount over here is missing. So we have 5 missing in this view. I'm just looking at the head over here. So this is customer head, payments head, and we can see over here the 60 missing for which data set we are looking at. Payments, okay, payments. So we see 60 over here, right? 60 total for the entire data set. And we can see paid amount, these are all missing. Okay, so we can only see 5 in this view because we're just looking at the head. So by default, this is 5 and this is 5. But if you don't put something in there, it will just go to 5, right? If you put something in there like 50, it will show you the top 50. Head is top and tail is bottom, okay? So what else? Fill in missing values. So display payments. Remember, .isNA_sum will show you the missing values per field or per feature. If you do it twice, .sum.sum, it shows you everything for the entire data frame. So I'm going to say payment method, fill NA with unknown, okay? And then display payments, payment method is NA. I want to count these and then just look at what's missing down here. So I'm going to do a filter for unknown. So Control Enter down here. So I see 63 records because I just added 3. Originally we had 60 missing. Now we have 3 new records. Okay, here's the paid amount. NAN, order payment ID. Now we're down to 60 because I filled these in, okay? And then I'm just filtering for what's unknown over here. Payment method is unknown. I'm filtering out this, right? So we have 60 records over here. Under payments, that's what we see over here, right? 60, actually 63 when I just introduced the 3 new ones. When I go ahead and fill those in, you can see it goes down to 60. And then if you just want to filter out and see what's unknown over here, payment method equals unknown, this would be the filtered part of that data frame. And we can see this down here. So we can see the 3 orders right here. So moving on to number 12, we can do fix the data types and force these to be of a certain type. So sometimes you'll get data, everything is an object, right? Like you can see down here, everything is set to object. But what if we really want a date to be an actual date, right? Some date, if this is an object, this is going to create nightmares for you. And it's going to be a lot of trouble if you're trying to do some type of difference between dates, taking a date and, adding 6 months or 3 months. Okay, something has to happen with this date 6 months from now. Okay, maybe it's a membership could be expiring, right? Or will expire as of a certain date. If these aren't actual dates, you are going to have a heck of a time doing any kind of date aggregation or calculations on dates, right? They really have to be a date. So you just have to convert this to date time. If there's any errors, we are going to coerce it and just say, Pandas, I know you're very sensitive and you're a very caring type of beast, but if there's an error, just coerce it into a date time anyways. Okay, so I'm going to say these are pretty much date times. If it gets something like this, it's actually not a date, it's going to throw a fit and throw an error, and your code is just not going to run, right? It's going to break down, and then you're going to be frustrated. the machine is not going to know what to do either, and it's just going to be a big mess. But if you could coerce these to true, even if there is something that's not a date in there, it's going to run and you can do your calculations, your aggregations, and whatever it is you need to do. So originally, sign up date is not a date. I am saying coerce to true and force that to be datetime. I don't care what you have to do in this universe, force it to be datetime. Okay, so sign up date and order TS. This is time series, I think. So if we look over here, sign up date and order TS. So the difference here actually is this is just a date. So you can see year, month, day, year, month, day, year, month, day. This is not a number. NaN is not a number. It's not filled in. And this is a date. Now, if you get order time series, you actually get the date and the time. So you can see this is 1300. This is 1 p.m. Oh, no. Oh, sorry. That's a date. That's a date over there. This is 11:38 a.m. 1:52 a.m. I think this is in 24 hours. So this is 1 minute after midnight. This is 10 o'clock in the morning and 3:39 a.m. I believe this is 24-hour format. If not, I mean, we can look at this. I'm just guessing offhand. I think that this is all 24 hours. If not, we can force it to be and get that straightened out and cleaned up. Okay. So this is what it looks like after. So the stamp date is actually a date. This is the date time. You can see by the date type over here. So the date type comes from right here, D type, right? So D type, print D type is data type. So you can see this has been actually converted to a real date time, as has this been converted to an actual date time. Now, if you want to convert this just to dates right here, because remember, you have the date and time series. So you have the date plus the time there. If you just want a date, you could just convert that to a date. If the time didn't exist, you can't just extract the time or try to interpolate the time or something like that. If the time isn't there, it's going to default either to midnight, or most likely there's not going to be any time. You can't just manufacture time. But if you had the date and the time and you just want the time, or just the hour, or just the date, the month, day, year, you could easily do that as well. Okay, now in the event that we have to create some new columns from existing columns or new features from existing features, this is called feature engineering. And like I was alluding to, maybe you just want the year, maybe you just want the day, maybe you want the month. Actually, I think this is the month, this is the day. Maybe you want the hour or the minute or the name of the day or the name of the month. There's all kinds of ways to do this. We'll take the original data frame from this orders table. That's what we're looking at. So the data frame is called orders. Again, course, if there's some issue with this and you get something like that kind of thing, that is not a number. That's certainly not a date. That's really nothing. So if you don't tell Pandas to coerce, I think this will do it, because I think the data is clean. Yeah, this works either way. But if the data was less than clean, and most of the time, guys, I've been doing this for 20-something years, the data is not clean and you have to clean it up. And honestly, like most of the time I spend just cleaning data. Like I do a lot of data science, machine learning, deep learning, artificial intelligence, but I'll tell you what, I'll spend the majority of my time just cleaning data, because if it's not in a good state, you can't do any data science. You can't do any machine learning. You can't do AI. AI won't exist unless you feed in pretty clean, pretty refined, pretty standardized data. If you just take a bunch of garbage and throw it into the machine, it's going to spit out a bunch of garbage right back to you, okay? It has to be in good shape. So a lot of times you have to do these data cleaning exercises, right? And if it comes in a little bit wacky or wackadoodle, I used to work with a girl that said that all the time. I thought that was kind of cute, a little bit annoying, just a tad bit, but wackadoodle was her word. If the data is less than pristine, aka wackadoodle, you have to clean it, okay? So this is a nice little trick. Dot errors or comma errors equal coerce, and then you have your month, day, month name, day name, hour, and minute, and this is all appending onto the same data frame, right? So the data frame, if you look closely, Control C, Control F, I'm going to search for this right now, comes from here, right? So here's customers, dot head, we're displaying that, and that's the customers data. This is the orders data, okay? Customers has a little issue over here. I don't care, because I'm looking at the orders data right now. So customers are customers, orders are orders. I'm reusing it over here and appending these new columns or new features, as they're called, onto the end of the data frame. So it ended over here. I think ship state was the last column. Then I created year, month, day. So we just parse this out, right? 2024, 113, that's how we get that. Pretty straightforward. Month name is January. So this is 01. That's going to be January. That's what I learned. That's what I learned when I was in school. When I was growing up, it was January. This is June, so we get a June over here. Saturday was that date. So if you look, June 8th, 2024, that should be a Saturday. That's what Pandas is telling me, so I'm going to go with it. If I go back to 2024, June 8th, yep, that's a Saturday. So we are fine there. Hour is 1 p.m., 52 minutes. Okay, so 1:52, and I guess this is 24 hours. So this is 1 o'clock and 1:52 a.m. By that time, I'm sleeping. I don't know what kind of transaction is being recorded. This is an order table, so someone's putting in an order. Maybe it's a nightclub. I don't know what this is, or a bar or something. 1:52, the order went in. So I'll probably be sleeping by that time, but this guy is doing transactions. And I don't think that's in the afternoon. Could be. I'm going to just guess that's AM, and this is 24-hour clock. Anyways, it doesn't really matter. That is how you do feature engineering on your Pandas data frame. So let's say we have to rename columns. Okay, we have full name over here, and this is customers. So if we go back here to customers, this is customers, and then orders, we have full name. Let's say we want to change the name to be customer name. This is how you can do it. Originally, it was full name, or we're just telling Pandas if you see anything called full name, copy paste it or just replace it, whatever you want to call it, with customer name. Now we have customer name. So we have the customers over here and the orders over here with some feature engineering built into it. So it looks pretty nice. So now we can also display duplicates and drop duplicates, or somehow manage how we have duplicate records. So I can pretty much guarantee you in any scenario, you don't want duplicate data. You see this show up, right? So what happens, you don't want it to happen. You don't want to double count receipts or transactions, right? If some customer comes into your bar and he's buying a drink at 1:52 a.m. on this date, this is a Saturday, June 6th, 2024, you're not going to double count that, right? If the customer came in and made a transaction, that's one transaction, you don't duplicate this. I've seen people do that accidentally, hopefully, not intentionally. I've seen dupes, triples, even quads in data, 4 records exactly the same. Sometimes people don't even know how to deal with it, which is unfortunate. That's where I come in and I have to help them out, right? But there's a couple things you can do. You can keep the first, you can keep the last. It doesn't even matter if these are all the same. Now, there could be different, like slightly different times, right? Like if one system captures a time in terms of minutes, and another in terms of seconds, another in terms of microseconds, you could have 2 transactions in the same minute. That could happen, not in microseconds. I don't think you can swipe your credit card that fast, but if you only need minute level details or minute level precision, maybe just keep the first record, keep the last. It doesn't matter, but you don't want duplicates. I can guarantee that. So if you have any duplicates, just eliminate them. Let me run this small block of code really quick. So before customer dedupe, we had 21,6. This is always row, comma, column. So we had 21 rows, 6 columns. We did have 2 duplicates right here. So we went from 21 down to 6, right? So that's what this does before customer ID. Keep the first. So we dropped these 2 records, but we're viewing the records, dupe groups. So the groups come in right here, dupe group. So that's kind of fun to say that, right? Dupe group. So duplicated, anything that's duplicated, we're looking for this, okay? If you want to drop duplicates, you can do it a couple of different ways. Keep the first and say not equal to. This little tilde character means not. So I'm not sure who invented this. That is a funny little character. Or it means, I think this actually means not in the set of. I think it means not in the set of. I have to Google that. So not equals to would be like this equals. So exclamation mark equals. Again, I don't know who came up with that. Some computer scientist probably 50 or 55 years ago. Who knows, right? Some people came up with that. Not equals to, and this is, I believe, not in the set of duplicated data. That's how we get keep after dedupes, okay? And then, again, there's a couple different ways to do this. I'm not saying this is absolutely the best. This is one way to handle duplicates, okay? Just be aware that just pick one thing that works for you and, build up some confidence around that, and that could be your go-to thing. There are several different ways. Like I could even Google this right now. Like show me a pandas data frame. Okay, so you can Google it, find something that you like. This is Google's relatively new AI tool, right? So it tries to anticipate what you want, and it gives you the AI summary first, AI overview. So I'm not sure. I don't think I've subscribed to this. It's just showed up. I'm not sure if you can turn it on or turn it off. But anyways, they have a couple different things they recommend. So df.drop_duplicate. So that's one way. So I'm using slightly different technique over here. This is not in the set of. So you can use drop._duplicates. In place equals true means that you don't have to copy that to another data frame. If you have to copy that to another data frame, then you have to use something like this, right? So this would be the original data frame. This would be the new data frame, okay? So you can copy it or just do in place equals true, drop_duplicate. So they're doing the same thing. So this is what I'm doing down here. Keep first, by default, keep last. Remove all occurrences of rows that are duplicated, leaving only truly unique rows. So there's another way. Okay, this is similar to the way I'm doing it. Keep last, keep first, in place equals true. You don't have to create another data frame, right? Otherwise, you'd have to do something like this. I'm not going to save this one. Just demo this down here. df equals drop duplicates. Okay, so if you don't have this line, you have to create a new data frame of your existing data frame. And you can keep it the same name, right? So this right here will replace this. Anything to the right of the equal sign gets overwritten by what's on the left of the equal sign. So there's many ways to skin the cat. That's what I'm trying to say, okay? So I'm using this, but by all means, just pick something that works for you. Build up your confidence around that. Build up your comfort level and use that technique. There's many ways to the same end, right? Different means to the same end. Different means to the same end. So drop duplicates. So here's another way. So I actually have that in the array. So after shape is 20, originally we had 2 duplicates, so we had 21 records. After we dedupe, we have 20, and you can see the evidence down here, the same thing. So we can sort rows. So customers dedupe. This is the deduped version of the duplicates, right? If I do Control F, you can see out here. Sorry, Control C, Control F. Okay. So here's the dedupe, right? And we're sorting values in this case. So this is the next Pandas technique that I'm showing. So number 15 out of 30, so about halfway there. So sort values, you can sort this, sign up date and state, and you can sort by multiple columns by just listing columns, and then set ascending equals true and true. So these are both set to true. If you had false and false, they would both be false, right? So it would be descending and not ascending. I don't even think Pandas has a command called descending. I think it's ascending equals true, and that's ascending, and ascending equals false, that's descending. So here you can see gold, silver, 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 bronze, Control Enter. Oh, invalid syntax. Okay, so let me do Control Enter over here. I think it's right. Oh. Custom. Oh, I must have overwritten something here. So it wasn't like that, right? Customers, is it this? Okay, let me figure this out. Somebody's knocking at my door. Hang on a second, I'll be right back. Okay, so yeah, in the interest of time, let's move on. I don't like it when these videos go to an hour. I'm already 34 minutes into it. But the point is here, ascending equals false or true. You can set this to what you want. And if you set one to true and the other to false, it just follows that convention. So you can say sign up date is ascending equals true. So this is in ascending order, increasing order, and descending would be top down, right? So the highest to the lowest would be descending, and ascending is lowest to highest. So if we sort by date, sign up date. So over here, you'll see that was ascending equals false. So you have the highest at the top, right? So this is May, April, 19 April 4th, May, February, right? If I reset that to true and not to false, that's going to flip. Now we have the lowest ones at the top. So January, February, June 2023, July, and then what's this, August, right? If I set that to false, you just flip it. Then we go back to 24, I think. Yeah, 24. May, April, March, February. Okay, so I mean, pretty intuitive, guys. I think you can figure it out. Pretty straightforward, right? So create new columns from existing columns. We saw an example of that before with the dates, right? Feature engineering. If you have a date, you can create the date, the day name, the month name, hour, month, year, minutes of the day, things like that, all these things, right? So over here, in this case, I have net unit price, and that is a function of unit price times discount rate. So if there's a discount rate, we see it over here, this is the net unit price times 0.01. So 1 minus this, so it's about 10% discount or 90% multiplied by 0.9, right? For a 10% discount, net unit price would be 284, sorry, to 316. You get a 10% discount, or and this is 90% less than this. Okay, so pretty straightforward, guys. So here's an example of where to do filtering. So NumPy where, you see this in the SQL world too. So SQL has a where clause, discount rate greater than 0. This is discounted, otherwise full price, and we assign this to this new feature. Okay, so this is another example of feature engineering, discount flag. So over here we had discount rate, unit price, and line revenue. We have the same over here, and we're assigning a new feature. Okay, feature engineering, discount flag, full. This is discounted because the discount rate, what's it say? Where discount rate greater than 0. Oh yeah, so this is greater than 0. This is discounted. So that's the logic. So pretty straightforward. String cleaning with .string. So we can clean up emails, clean up anything that is messy or missing, or just sometimes you have to refine the data and just get it into a state that is more comprehensive and more complete. If you had to do something like this, and again, this is just one example, there are hundreds of different techniques out there, guys, and hundreds of different things that you'll probably encounter in your career. This is just one. If you have an email that looks like a standard email address and you just want the email domain, this would be example.com. Or this over here, if you don't want the entire email and just the domain, you can get it over there. So that's just another use. And again, this is just one use case, right? You have to use your imagination and try to think of other applications for these types of things, right? The sky's the limit. It's almost really anything you can think of. I always tell people all the time, the only limitation is your own imagination. Here, we're parsing out email domain. If you needed to do something else, just think about it, Google it. ChatGPT is your friend, and you are in business, guys. So this is an example of bin numeric cut. So pd.cut. I found a good website. I could share it for you guys. Let me see. Pandas cut function, cut versus qcut. There was one that really stood out to me. I like this a lot. I'll try to find it here and share it with you guys. Oh yeah, here it is. Bending data with pandas cut. I think this is great if you get into this stuff. I have used this quite a bit. Let's put a little note in there. Go ahead and check out that resource. They have all kinds of different examples for all kinds of different things. So here we'll have, I think, 5 different bins. So this is 1, 2, 3, 4, and 5. And we just have different states. So if it's between this and that, that is 1. Between this and that, that is 2. Between this and that, that is 3. Between this and that, that is 4. So we have 4 bins over here, with the lower being 0 and the upper threshold being 9999. So based on the MSRP, we can put these into bands or buckets or groups, or whatever you want to call it. A group and a bucket, it's the same thing to me. So based on MSRP, we have these bands right here. So this is luxury. Anything greater than 150 and less than 1999 is luxury, and this is premium, 137. So that falls within this band right here. Here's premium and here's luxury, guys. So just one more thing that you can do with pandas data frames, right? There's a whole bunch. And then if you want to look just at these bins without all the data behind it, you can take a subset of that. Like we saw before, we were taking a filter. I showed you a couple actually. So there's a filter over here with the where clause. So here's one way to apply a new flag. Or if you just want to filter out items into a totally different data frame, you can just filter these items, just say new data frame. You have something like that and append everything. What's that supposed to be? New, not DW. What was that? I don't even know what that is. New data frame. If you want to do that, that's another way you can manage this stuff. And if you just wanted to filter out, there was another example over here. Oh, I think it was the customer duplicates, right? If we just want to see the duplicates, we could filter those out. Where was it? Oh yeah, here's that little weird character. I think this means does not exist within the group of or something like that. You can Google it. What does the tilde key mean? And pandas, let me see this thing here. It's going to go over an hour. I can tell it. This video is going so long. What does pandas Python? Okay, so Google it, guys. If there's something you don't understand, just Google it. Oh, it's not really giving me an answer. That's interesting. Mean, what does... Oh, I didn't have the character. Okay. I think it's called tilde. Oh, not. Okay, so not in the group of, not equal to, is in the group, not is not in the group. Okay, so here's an example. Not in, or not. It just means not, is in. So if you're looking for is in city London, this will give you London. If you have this little character over here, I believe this is called a tilde. This sets everything to not equal to, okay? So I don't know who comes up with this stuff, guys, but it's brilliant. It's brilliant, definitely. Okay, so we have the PD cuts. I showed you that. What's next here? 20 to 22, filtering is selecting. Okay, so yet another way to do filtering. So here I'm creating a brand new data frame like I showed you before. This is creating a new field in the existing data frame, okay? And then we're appending data into that new field. So anything to the right of the equal sign gets assigned to what's on the left. So we have the data frame here and the field name over here. If you want to assign everything to a brand new data frame, we can do that too. This is saying what? Return engine? Wait a second. Line revenue. Line revenue doesn't exist. Wait a second. Why does my line revenue not exist? Okay. Let me troubleshoot. Okay, so I'm looking at the fields in this data frame or features. You can call it whatever you want. I have line revenue equals orders. Or order items. This is a data frame. This is the feature name quantity times unit price. So line revenue is that quantity and unit price, right? So multiply those two together. Anything with line revenue greater than 90th percentile quantile is going to be high value items, and all the high value items are going to be over here. Okay, so unit prices are higher and quantity is higher too. So these are higher value items, maybe in some type of shipment or something. And if we look at the original data frame, let's see, yeah. The original data frame had a shape of 140 records. So again, rows, comma, columns, 140 rows, 7 columns, the high value items that consist of the top 90% most expensive, right? Top 90th percent quantile. There are 14 items that exist in this group out of 140, so 10%, right? So 10%, quantile 90, top 10%, you're getting 10%. So 14 out of 140. So another technique that you will use over and over and over and you'll never stop it, is the ilocation. This is the integer-based position, and location, this is label-based position, okay? So when we do slicing is when you pick certain columns or certain rows from the entire data frame here. I'm looking at everything in this data frame. That's 140 rows. This is 140 rows. This is 14. If we want to look at a certain subsection, we can use the .i location and dot location, right? So this is label-based, looking for column names. That would be one example. And integer-based starts at 0, so everything is 0 based in Python. start at 0 and go up to the number of records that you have in the data frame, right? Over here, it's 14, and 14, and over here, it's 140, okay? So a couple examples of this is location and ilocation. So ilocation, again, looking at integer. So this is based on the position. So looking at the first position in this data frame. So ilocation, basically 0. This is the first item in this data frame right here, customer ID. You'll see it matches this thing over here if you look at this. Or order ID, right? Is this order ID? Yeah. Oh, no, customer ID. Customer name, state, customers dupe. Okay, so we're looking at different data frames. Okay, so this is high value, and this is order items, and this is customer dupes. So we switch back to that. Let me just take a quick look at this thing, see what this looks like. Yes, okay, so customer name and customer name, email, state, sign up, date, loyalty tier, and then email domain, and we see the same thing over here. Okay, so that's what that is. So this is location. If you're looking for an index label or an index name, you can use the .loc. If you're looking for the index location, it's .I, short for index, and location. Okay, so just play around with it. I mean, it's pretty intuitive. The first time you use it, maybe not, but you get used to it pretty quickly. This is integer-based positioning and label-based. So basically, LOC is things looking for like maybe column names. If you want to look for a specific column, you would use the LOC. If you want to look for the integer location, this would be column number 2. So 0, 1, 2. Remember, it's always 0 based. And if you want row number 3 or row number 2, this would be row 0. This would be row 1, and this would be row 2. So column 2 and row 2 is right here. So 0, 1, 2 for the columns, and then 0, 1, 2 for the rows. So this would be row 2 and column 2. Email on line 2 for this person right here. Okay, so yeah, just play around with it. I mean, it's pretty intuitive. You get used to it pretty quickly. This is location. Record number 1418 is 0. If I run that, control enter to run, and it gives me some weird output here. Let me see, customer dupe. Oh, it says I can't find it. Maybe I have to build that. Okay, so let me go over here. Customer dupe, right? Customer dupe. Okay, location 1. Okay, so that's fine. And then 1418 1. Okay, I think I dropped the other one or something like that. It doesn't exist, whatever. So here's row 1418 1, and we're finding the location right here. If you want the I location, this is the index location, just use that. Another example of location, again, we're dealing with names. So I is the index. Index is going to be a number. LOC is location based on name. So it's pretty intuitive. I mean, I think you pick it up pretty quick. It does take a little getting used to, and you have to do this stuff a couple of times. I always do these demos for you guys. So you can download the code. I'm going to share all this code with you. I'm going to hand it over when I drop the video a little bit later today. I'll put that up on YouTube. I was going to try to drop 3. I don't know if I'm going to get to 3 today, but let me see how it goes. So I do all the coding so I can learn from this stuff. So it's a little bit selfish. Every time I do these things, it's for my own benefit, but I do a lot of this research and share everything with you guys so you can learn from it too. But you do have to copy and paste the code and run it. That's how you're going to learn. If you just watch the video and you're eating a snack and you have your chips and your hummus, right, and take a couple bites and chew in, take a couple more bites and chew, 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 bite, 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 chew, chew, bite, bite. You're not going to learn as much. If you get your hands on the keyboard, copy and paste at least and run the code, you're going to learn a ton. And, you know, add new things, make a couple of mistakes, try something, okay? Email domain. So I have 3 column names right here. If I add a 4th, what is going to happen? I'm going to see these 4 columns come through when I run the code, right? So things like that should be pretty intuitive, but you don't know until you actually try it and actually do it. So if you think you know something, Maybe you do, maybe you don't. If you do something and you know how it works, then you do know it, okay? So if you think you know it, you might or you might not know it. If you try it and you do it, then you know it, okay? So that's the difference. So I would implore everybody to copy and paste the code, run it, and see what the output is, right? Check what the output is. Does it match your expectations? Yes or no? If yes, then you know what's going on. If no, then there's an issue somewhere and you have to resolve it. Okay, so again, iLocation, looking for the location of this request right here. So customer duplication, iLocation. So we're looking for 0 to 3. So the first 3 records here, or the first 3 columns, right? So we have these right here. If I go to 4, then we're going to have 4, right? So that's it. So pretty intuitive, guys. But again, just play around with it, test it, see how it works. Then you know how it works. If you just watch the video, maybe you know and maybe you don't know, okay? This is an example, again, of slicing. There's so many different things you can do with slicers. Just try a few of them, get warmed up, get used to the conventions here, and then you can do some really cool, really powerful stuff. This is the last 3 rows, so we're going negative in the first 4 columns. And again, the convention is always row, comma, column. Excel is the same way. If you're doing like an offset or something in Excel, it's always row, comma, column. These guys follow the same convention as Excel, so that's helpful. So if you know one, you can learn the other super quick. So this is location. I'm looking for the first column starting with customer name and the last one starting with sign up date, and I'm getting everything in between. This is customer dupe. If I go back here, what does this look like again? Customer dupe looks like, oh yeah, so email domain. So if I wanted to do something like state and loyalty tier, I could do that. So I'd get the beginning and ending, and it should show me these 3. So I'm going to look for the first column and the last column within my slicing request here, and I should get sign up to. So if I go on here, boom, 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 boom. Loyalty tier. What's the first one? I already forgot. State. Oh yeah, state. State lowercase. Okay. Sign up date. So that's how that works. So just just try it, play around with it, get acquainted with that, and you can do some cool things. Again, row, comma, column. That is the convention. So we're up to item number 22. So this is a query similar to what you would see with SQL. So if you're coming here from a SQL background, this is the .query operator in Pandas. So you have this original data frame that came from way back at the beginning. Remember when I set this up, we had these web events, web marketing event, or whatever you want to call this thing, right? So that's a web event. So it's from that. And if you look close, the syntax is going to be pretty similar. Or is it 20 through 22? Go back a little bit. It's going to be pretty similar to what you would see in the SQL world. So .query, this is the query, this is the question. Query is another word for question. We're asking a question where device equals mobile and UTM source equals Google. So you can see device is mobile and UTM source is Google. And if I go back here, look at this. Oops, down to the next. Wait, what was that? Oh, actually paste it and then went down. Okay, whatever. What else? So if I want desktop and email, I could do that. And you can guess what's going to be returned here, desktop and email. Okay, so just another way to do a filtering for your data. We saw a few different techniques already. So let me look quickly at 3 tables. I can take this out. This is just empty space. It doesn't do anything whatsoever. So I have 3 tables here. I have an orders, a customer, dupe, and a product table. So here's my orders, customer, dupe, and product. Let's say I want to join everything together. So I can have a big amalgamation of everything all in one place, everything everywhere all at once. So there's a movie that came out about that. It was a kind of cool movie. A little bit confusing. I mean, you can't be having any kind of wine or beer when you're watching that movie. That's kind of a, you got to pay full attention. That's what I'm trying to say about that one. So everything everywhere all at once. If you want to do this, you can use the merge operator down here. So I want to merge whatever's at the beginning and whatever comes next after the merge operator. So I'm going to do order items and orders. Okay, so this comes from this table right here, orders table and order items. If I look at that, let me just take a look at this thing too. And I'll put this thing in between just to separate it. Makes it just a tad bit easier to read, I think. Okay, so we have the order items, the orders, the customer dupes, and the products. These are the 4 tables that we're looking at. And we want to join the order items with orders based on the order ID. So that is what we're going to do here. So here's the first data frame. Here's the second items. Sorry, order items is number 1. This is number 2. We're going to join on the order ID and left. So everything in the left data frame, which is this one, and all the matches on the right. If I did inner, this is just like SQL. You can do inner. You might drop some, right? There has to be a match between that data frame and that data frame based on the order ID to get the inner return, and that's totally fine. If I do this, let me see how many we get. Might be the same if all these are filled in. If not, that's going to be slightly different, right? So we have 60. I think this will be the same. We get 60 again. Yeah, so there's nothing missing. All these numbers match. If they did not match, we would pull everything on the left table over here and all the matches on the right. If we're using an inner join, but everything matches, so inner, left, right, it doesn't matter. It's always going to be the same. Now we have this. Everything is appended, or actually merged. Append is slightly different. Sorry, I misspoke. Everything is merged from orders into order items. Then we're taking order items again. So we're doing another merge onto customers dupe. So this would be the next table. So remember, a little confusing, but not too bad, guys. This is the order item. This is table number 1. Orders is table number 2. So we just merged these 2 together based on the order ID. Now we're going to take the customer dupe. After these 2 are merged together, we have a table with all of these fields in it, or all of these features in it. Now we're going to add in a third table. So this is going to be customers dupe. That's this table down here. So 1 and 2 is merged into 1. That 1, that big table that we just created, gets merged with this one. So that becomes a large table, right, by adding in these extra rows. And then that one gets merged a 4th time with this table down here. Okay, so we have order items right here doing a merge with this. Then customer dupe with this. Okay, this is going to be left join. I'll keep these consistent. I'll just keep it left. On customer ID and then on product ID, because now we have products in this table. So we have product ID over here. And where's the other product ID? I saw it somewhere here. Our product ID over here. So we need order ID to order ID down here. And then customer ID to customer ID. That's how we're doing the merge here. And then product ID to product ID, which comes from the original table, which was merged with the second and third table. So everything is merged together. So we have the order ID, product ID. Then we pick up the customer ID. We can merge to this table, and this was in the original table, so we can merge to that. And all of that is in the details down here. So I'm merging this to this on the order ID, this to this on the customer ID. Okay, and then this to these 2, which would just merge together into the other merge. We're pulling in the products based on the product ID and the left merge. So everything on the left side, this is always going to be the left. So that's the left of these 2. This actually is the left of this, because this is merged into that one. And then this is the left of that, because these are merged together. Okay, so it's a little bit, but I think you get it. Hope so. So Control Enter. Okay, everything looks good. We have one massive table due to all the merges. We have 60 rows, 5 columns down here. But what did we have on the original orders total? So this becomes orders total. I want to see the actual shape of this thing at the end. I don't even care about that. That one's going to be that. Okay. Control Enter. So the order table is getting pretty big. I don't even need that. Attack order. Oh, no. I'm just looking at something here. Oh, because that is decrease. Okay, so I see it. So fact order items. So order items. So I want this shape over here. Yeah, that's what, okay. I want to see how many columns exist in that because we did 4 merges. Well, 3 actually. So this is merge 1, this is 2, this is 3. Merging 4 tables. So that's table 1, table 2, table 3, table 4. I want to see how big that table is. So dot shape is going to tell me the shape of the object. The object is a data frame. And we're going to look at rows, comma, columns. Control Enter to run this. So pretty big, guys. We have 140 rows and 27 columns, right? So here's all the columns over here. If I copy and paste that into Excel, we should see 27. So 24, how many letters in the alphabet? 24, 26. I actually get that confused all the time. I don't know why. 24 letters in the alphabet or 26. I don't know. We have 27 columns. So let's see what this thing looks like. Column AA it goes out to, or ABC or AC, one of these. Let me see here. Okay, that is the index, so I can cut that over, put that over there. AB, oh, okay, so we have 26 letters in the alphabet and 27 rows here. Control left, count 27, so there's the 27 columns, and it all comes from these 3 merges. So we started with this, 1, 2, 3, 4, 5, 6, 7, 7 plus whatever this is, plus that, and we have 27 columns. Okay, so hopefully you get the concept, you get the idea there. That is pretty cool. So the next thing here, remove any existing order, like columns to avoid suffix collisions. Yeah, this could happen. So this is a case where you merge 2 data frames together and they have the exact same column name. So typically, sorry, I keep coughing. I've had this condition for at least a decade now. This acid reflux, it just doesn't go away. No matter how many doctors I see, it just doesn't end. So kind of gave up on that. It's just living with it now. So anyways, if you have a conflict name collision where you have 2 names identically the same, typically Pandas will have a column X and a column Y, and it just prevents any errors from occurring. You get your merged data frame in the end and everybody's happy. Now they could have different names. The naming convention is going to be X and Y, so they append an X onto the beginning and a Y. So if you're looking for that column name, it could be renamed something different. So to prevent that from happening, you can use this technique. If the columns exist, either overwrite it, write it with a more intuitive name, or drop it if you have duplicate names in the same data frame. It's not going to work, right? It's going to cause an error, or Pandas is going to revert to the X and the Y convention, right? So, so you have to call it a slightly different name, or just drop it, okay? There's a couple different ways of handling that. Control Enter. And then we have the shape, and then the product shape again. So I'm looking at 10 rows, 6 columns. Control Enter. That's what I see here. Here's the 6 columns. It goes down to 10 rows. So we're up to item number 24 out of 30. So we're getting there. We're doing good. We're doing good. We're over 1 hour in time. I'm sorry. I apologize. These things just get, it's been out of control. I thought this was going to be a half hour. Now I'm at an hour and 3 minutes. And I still have a couple items I want to cover. So concat now. We'll take everything and instead of merging, which extends it out to the right? The data frame grows bigger and bigger in terms of columns. Concat will almost do what a union does in SQL and appends everything underneath, okay? So it really depends what you want to do with your data frame. Now the structure has to be the same. You can see that these have the same structure, okay? So we have products and product updates. So if you want to take everything from this and append it into this, you can take one and drop it underneath the other one, and everything is going to have the same columns. You're going to have a lot more rows now, but the same columns, same structure, same exact data structure. If you want to merge out to the right, you can merge new columns out to the right as well, okay? Now, it really depends what you're trying to do. Obviously, these columns are all the same. It wouldn't make sense to have a product ID 1 and a product ID 2, SKU1, SKU2. Or in this way, if you did try to merge, you would have X product ID, X SKU, X category, X brand, X manufacturer suggested retail price, and M, and X MSRP brand, and then you have Y for all these. That makes no sense. So you would not merge this type of data together. You concatenate it. Okay, that's what we're doing here. We're taking Pandas data frame. Data frame number 1 is product. Number 2 is products update. You can see product over here, product update over here. Same exact data structure, same heading, same naming convention. So you take one, append it underneath, right? Or take it or just push underneath. So this is what you would use concat for. If you want to do a merge and have new columns appended over to the right, this is a great example of a merge. Okay, so we started with, what is it, 7 columns, 1, 2, 3, 4, 5, 6, 7, ended up with 27, right? So we have 140 rows, 27 column. Remember, it's always row, comma, column. So we went from 7 to 27, and this is fine. We have all new items over here. This actually didn't exist. So if the state doesn't exist, it just has a nan, not a number, but there's a placeholder for that, right? We can try to backfill that. We can fill in these data points if that's necessary. Maybe it doesn't even matter. But I want you to know, like, if you have different column names and you want to get everything merged together into one large data frame, this is how you do it, right? With the merge operator. If you have the same structure, like these two, and you want to take some data and push new data onto the bottom of it and extend that down in terms of increasing the number of rows, then you would use concat for that, right? So very different technique, very different methodology there. Just make sure you know what the differences are, okay? I have a couple things in my notes here. So merge and concat are very different, and they solve different types of problems. So the merge is a little bit like a join in SQL. If you join two tables together, you have table number 1, table number 2, you marry them together. Now you have one single table with all the data from 1 and 2 merged together. Concat is stacking or gluing something. So you have the first data set, the second gets glued underneath the first. Okay, so that's how these things work. So just make sure you understand the difference. If not, Google it, ChatGPT, right? These things are your friends. Batch ingest, concat, web events. Again, we're doing concatenation. So we have January, February, March. If we go back to the beginning, these three were almost the same thing, just different months, right? We got the data like this. So this is a perfect example of concatenation, right? We have the web data from January. This is probably web marketing, something or other. So you have January, February, paste it underneath. The only thing that's going to be different is you have more rows. You have the February rows. The structure of the table is the same. The headers or the column names are exactly the same. Next month, March, append that underneath. That is a concatenation, right? So perfect example of concatenation. I don't think you want January, then February next to that, and then March next to that. Now, I have seen that could work. Really depends on the scenario that you are after, or the environment that you operate in. But it's probably going to be concat. Certainly in the database world, you would have long tables and lots of records, lots of rows in those tables, but not too many columns, right? If you want a that would be a long format, right? We have a big long table. If you have a wide format, then you would have a lot of columns, right? So it really depends on what you're trying to accomplish. Wide is lots of columns, that's a merge. Long is a very long table, lots of records, but not too many columns. That would be a concat, okay? So let's look at, let's move on here, 26 to 29. I know we're dragging on almost an hour and 10 minutes into this. I thought it was gonna be 30, honestly, guys. So this is pretty straightforward. I'll rush through to the end. Aggregation and reshaping. Let's say you have a large data frame, fact order items. I want to do some aggregation. So aggregation is basically sum, count, take an average, find all the unique numbers, something like that. There's a bunch of different things you can do, but not that many. There's a very finite number of expectations and utilizations for this type of thing. So if I'm doing aggregation, I'm doing a few different things all at the same time. So you don't have to do this separate and distinct. You can merge everything together, or maybe merge is not the right word exactly because we're just talking about merges and concatenations, but you can blend everything together into the .ag. So this is the concept over here, .ag. I want all the unique orders, all the unique customers, okay, so customer ID, and count the unique customers. I want to count of these. And for revenue, I actually want a sum. So I want to take this and add everything together. When I take the orders and customers, I'm going to condense everything or compress everything into unique records for orders and customers and sum up all of the customer records. So you would see this on your credit card. I'm sorry, the bank would see this, right? So the bank has a big perspective, the parent view, the credit card customers would be kind of like the children. So if the bank wants to aggregate all the credit card transactions for every person, you would do a group by order, right? And then sum up all the credit card transactions. That's how they prepare your monthly statement. That's how they send it out to you, whether you log into the website or you get it through the mail. So that's what the bank is doing. They're aggregating. This is .ag based on customer, right? Not really orders. They don't care about the orders. Although it could be. They could look at the orders. Definitely the customers are being aggregated and the revenue. So it depends, right? If you want to see order level detail, they would include that. If you don't care about the orders, you would remove that, right? Average item would just be the mean or the average for the price. So we take everything, aggregate it together. That's what this is for. We're looking at all the unique orders, all the unique customers, and summing revenue and getting average price for that. Okay. Says something's off. Net unit price does not exist. So where is this right here? Let me see. Fact item order. Let's be missing column. Let's see. So net unit price doesn't exist. Let me just pick another one. Doesn't even matter, right? Line revenue. Oh, just unit price. Okay. Okay, so here's the aggregation. Again, all these orders are going to be unique now. I am taking the average item price. So we should see that over here. Looking for this. Average item price, orders. Oh, KPI by state. So that is, I think that's the right one. Oh, I see. It's doing it down here. Okay, so so I was displaying two things, right? So display fact order items. I already had it over there. So I'm going to get rid of that. I was a little bit confused. Okay. So these are all the details, right? These are the fact order items displayed here. This is a summarization. So everything here is unique in terms of customer. All the revenue is summed, and we can see the average over here. So that's what this gives us, right? So orders is coming over here. And ship state is actually the index. So we have the ship state as the index, orders comes true, and the index equals false. If I want to change that, I could actually set that as the index. Then the state comes a little bit here. You can see kind of like the different appearance over here. So you see ship state as the index, right? So that is the unique identifier for all these records. And then you have the items over here, which coincides with orders, customers, revenue, and average item price. If we set that to false, you have the row count as the index. So here's row 5, 0, 1, 4, 3, and the order doesn't matter, right? It's just an index. But these are all unique over here. If you want the ship state as the index, that's fine. Personal preference doesn't matter, right? It doesn't really matter. Control Enter, pivot table. So now we can take all the data. So this is another Pandas way of manipulating the data, right? We do aggregations, which is unique counts, summing, mean. So sometimes the transformation is a little bit different. It's not aggregating or summing anything like this, but we take it and actually change the view. So we have fact order items, right? So I look at this over here. Let me see what this looks like originally. Okay, so we take this large table that we saw before. The index becomes a category, so that is going to be on the left-hand side. Everything is going to be unique and distinct. The columns is going to consist of the channel. So if I look over here, where's the channel? Oh, seeing it. It's got to be here somewhere. Oh, here it is. So web, store, mobile. Okay. Value is going to be line revenue, so that is over here. And we're going to take the value and sum it. If we take the mean, we can do that. Okay, and the means average for all the line items would be over here. If we want to sum it, we can do that. Okay, so this is a sum. And if we want to count, we You can count the number of items. We have 10 items sold, 7, 11, 10. I think sum makes sense in this case. And it goes back to what I said before. Most of the time, you have a sum, a count, a mean, which is an average, okay? In the statistics world, we call it mean. In the non-statistics world, we call it average. Exactly the same thing. You have those three. So sum, count, average. You can have a min or a max. That is most of the types of aggregations that you see. These are the minimum values. Max would be max, right? And there's others. There's standard deviation. I think it's abbreviated like that. What's not spelled out? I forgot how they do that. Anyways, go with sum over here. But there's a few that you can use. There's probably a dozen or so, but there's not tons and tons and tons, right? So you see these types of things over and over. Sum, mean, count, sometimes min, sometimes max, sometimes standard deviation. Let me see. Pivot, PD, pivot table, ag. I know there's a standard deviation over here, but I forgot what they call it. These naming conventions are a little bit different. Ag functions. Oh, NumPy standard deviation. Okay, that's what they call it. So this is a NumPy thing over here. Oh. Oh, wait. Did it have the whole thing? Is that how they do it? Oh, they don't have the quote. Okay. Okay, I see. This one is a little bit different. I'll get rid of that. I should run. Okay, so there's the standard deviation. That was a lot of work. Okay. So we go back to sum. I like this. That is pretty common. You see that all over the place. A couple more things here. Melt. So what I was talking about before is you can have a wide data frame, right, with lots and lots of columns. You can take everything and melt it so you have a long data frame, and this is very helpful for plotting if you have to do some type of plotly chart. So this is pivot revenue. That's what I had over here. So this is the pivot revenue. I'm displaying that. If you want to take that and just reframe that, this is going to be very hard to plot right here because you have what's called a multi-level, multi-axis, multi-level, multi-index data frame. Okay, this is a multi-index data frame. So it looks pretty straightforward, but you actually have an index over here, which makes it very hard to plot these things. You really want to get it into this format with 0, 1, 2, 3, 4. This is going to be the index. These are actually category names or field names or features. This looks like a feature, but it's really not because you have this feature stacked on top of this feature. This is why it's a multi-index data frame. So to plot this is doable, but it's kind of crazy, guys. You don't even want to go down that path. I've done this before, especially when it's bigger and more complex. Don't even get involved. Take it and melt it, and then you can plot it very easily. So this is just reset index to get rid of this index. Again, this is multi-index data frame. Reset the index, melt it with the category on the top. Okay, so these are the ID variables. The variable name is going to be channel. So the channel comes from over here. So channel is what? If we go back to the original data frame, it's like web, store, mobile, things like that. And the value name is going to be revenue. So we are going to include some kind of revenue. I want to plot this. So Control Enter to refresh this. Then I can easily do the plot. Once I reset the index on the data frame, okay, dot reset index and melt it. So again, taking everything from wide. If you look over here, this is a wide data frame, guys. This is 27 different fields. I'm not plotting 27 fields, okay? I'm taking this, pivoting this so it's easier to see. For my stakeholders, I can present this to them. Okay, mobile books did 47K in business. Store did 35K. Web did 10K for books. Very simple, very straightforward. Melting it, we can see all the details here. Then when I have a melt, I can very easily set up a plotly data frame. This is the pivot long. Remember, we had a wide data frame. We take it and just take 3 categories over here and make it very long and stretch it out. Then all I need is the name of the data frame. The X category is on the bottom. This is horizontal. Y is revenue, vertical. And the color is going to be channel. So we have books, electronics, fitness, home. You can see books and electronics perform pretty well. Electronics is definitely number 1. That is apparent in this chart. Fitness is last. This home is kind of in between. I guess it would be 1, 2, 3, 4, like that. You don't really get that from this view. I mean, it's all there, but it's a little bit hard to visualize. Down here, it's very easy. I like these plotly charts. You can zoom in and zoom out and double click to where you were before and get back to the original view. And then you can turn these on and turn these off, right, if you want to see that, right? So pretty dynamic and interactive. Let's look at just one or two more examples here. We're down to the last two, okay? I said 30, we're on 29, 30. Crosstab is a little bit like a pivot table where you have pd.crosstab. So this is pandas.crosstab. Web events is the device, like we saw before. Web events is device, and web events is event. So we have two, and normalize is going to be index. So we have the normal index. Again, just switching this around a little bit. This looks a little bit like the pivot table that we saw over here. So this is a pivot of the data frame. This is a crosstab of the data frame, and they are very similar. Honestly, like I don't even know what the difference is. There's a slight difference here. I forgot what it is. Okay, so array-like objects acquires a data frame as an input. Okay. So slightly different data structure input. Primary use ideal for frequency counts and analyzing, suitable for multidimensional analysis. Normalization does not built-in normalization. Flexibility, less flexible, mainly designed for simple crosstab calculations and more flexible. Okay, so they're different. These things are different. The view is kind of the same. We have the multi-level index. Over here you have the headers, and then you have the index over here, desktop or mobile. So the view is kind of the same as a pivot table, but I guess the functionality is a little different. That's fine. I mean, just different strokes for different folks. So number 30, we made it, guys. We made it through this marathon. The last thing I'm going to show you here is time series, resample, and rolling. So we're going to go back to the fact order items, back to aggregation like I showed you before. Orders, I want all the unique orders. I want to sum the revenue and my unique customers. And I'm going to sort everything by order date. So anytime you look at time series, it has to be ordered, because if it's not, it's not going to make any sense. You'll have lines going cross back and forth and weirdness. It won't make any sense whatsoever. You have to have the earlier dates on the left and the later dates on the right. Otherwise, yeah, really quickly, like you're gonna get screwed up. Okay, it won't make any sense. Just make sure that you sort that. We saw an example of sorting before, so here's a pretty practical use case for that. Now, the thing that I want to introduce you to you here is rolling 7 days. Okay, minimum number of periods is 1. So we're going to look at this every 1 day, rolling for 7. And it's up to you how you do this. You can do 7, 14. You can do every 28 days, 30, whatever you want, right? It's really up to you what you're trying to do. But it's nice how you have this kind of flexibility. You can pick the number of rolling days. Dot mean is pretty standard here. We're looking at the average movement of these KPIs. Moving average, this is MA, is moving average over 7 days. So this is a very common metric. You see this in the business world all the time. So we have daily KPIs. We have the 7-day moving average and resample weekly. So this is going to make sure that we get new data, or the data is refreshed on a weekly basis. And if data is output from some source, some government source or some educational whatever, sometimes you have to resample to get these indices aligned. So you don't see that in this case. They actually made up all this data here. But sometimes some numbers are just output quarterly, some numbers are output monthly, some are daily, some are weekly, some are annual. If you're trying to compare apples to apples and you only get quarterly data, or you get some quarterly data and some weekly, you're going to have to resample the weekly to quarterly to get those to sync up, either month end or first day of the month, last day of the month, something like that. That's pretty common. You would resample on that same frequency. Then you can merge those together, like we saw before with the merge example, and then you can do your analysis. So resample is very useful in some cases, but you can't compare weekly data to quarterly or monthly data. It doesn't make sense. You have to resample to the same frequency, okay? So just keep that in mind. Control Enter to run this. And let me look at the 3 charts. So I have a bar chart over here, plotly bar, plotly line, plotly scatter. Over here, I use a plotly bar. If I do a line, it looks a little bit weird, I think. It doesn't really pop for me. If I do scatter, I don't think this is going to present too well. It doesn't even have it. Okay. So this has to be bar. Okay. But anyways, the chart has to match the data and has to tell an interesting story, right? So I think the story is pretty clear here. Electronics is number 1, fitness, home, books is number 2, 3, and 4. Okay, and like I was just saying, so this image tells a pretty clear story. And again, like the chart really has to answer a lot of questions, not generate questions. If your audience is looking at this and saying, I'm very confused, or I really don't know what this means, or it creates a whole bunch of questions and confusion, your chart is not helping. It should be very clear, very concise, very crisp, right? And the chart tells you exactly what's happening. This chart was not sorted. I sorted this one in order, so Control Enter, just so we can see in descending order how this chart looks. We can do sort values by revenue, and ascending equals false. If this was to be true, this would be descending. Oops. You actually have to spell it right? So then we have increasing. I think this is more poignant. Decreasing. So electronics clearly was the best performer and fitness was the least. So we saw the crosstab. The last thing here is the different bar charts. So I have bar over here, line chart, and scatter chart, just 3 different types of charts to illustrate the point of what we're doing. Different strokes for different folks. I think they're all okay here. I like the bar chart. The line does work. Again, it has to be in ascending order. So left to right, we can see the dates are increasing. If you did not do this, or if I just comment this out and run this, okay, and refresh this, I might get it by default. Yeah, it's already stuck in the memory. Okay, so it doesn't matter at this point. But if I didn't have the sort order and the dates were just random, the lines would crisscross back and forth. It wouldn't make a lot of sense. In this case, everything looks fine, so it's okay, right? You want the dates in increasing order. So you see February, April, May, June, July. The line chart is okay. This purple one kind of drops off here. So what is this telling me? What's the purple? Customer. Oh, just the customer. Okay, so they bought a couple things over here. They had 4 purchases. Over here they had 4 at the beginning. Purple customer had I was looking at revenue. Okay, so revenue, right? So they spent less money, then increased the money, then increased a little bit more. So that's okay. The line chart isn't really doing it for me. I think the bar chart is interesting. Number of customers spent 7,164 in May. So clearly May was a real banging month. We did pretty good in May. July kind of suffered a little bit. June only had 1 transaction, that looks like over here. So that is okay. That tells a more important story or more convincing story, I think, the bar chart than the line chart. The line is a little bit confusing. Scatter plot really isn't doing it for me, but you just have to try these different charts and see what works and what doesn't work. So I would probably get rid of these 2, right, and just take this to my stakeholders and be done with it. But I mean, it really depends on the data that you're working with. The bar chart could be fantastic. Line chart could be great for time series, and scatter plots could be fantastic when you're trying to show X and Y fallout on these 2 axes, right? And you want to see where it goes. So that could be a good choice. In this case, I don't really feel like it's working. I think the bar is really the best, but again, just personal preference. I'll probably turn these off and just leave that out. Okay. So Control question mark to comment that out. So I'm going to save this, right? Save 36 minutes ago. Let me update that. So I have all the changes fresh and shiny and new. I'm going to export that. And I'm going to give you guys this file. You can download the HTML. You'll have everything for the top 30 most common things to do with Python. Pandas, this is a package I'm working with here. So that's it, guys. I'm going to wrap it up. I've already put in, God, an hour and a half. This has got to be the longest video. I'm sorry. This is torture. It's torture for me and for you. I thought it was going to be 30 minutes, 30 pandas techniques in 30 minutes. It didn't work out like that. But okay, sometimes things in life don't work out the way you think they will, right? And that's called life. That's what that is. Okay, we have a word for that. It's called life. When things don't work out like you think they will. That's it. I'm going to wrap it up. Thanks for your time and attention today. Appreciate it. I'll drop the code. I'll drop the video later today, and I'll see you guys in the next one. Take care from now. Yeah, and I'm going to put out a couple more videos. I think I have 3 more ready to go. I just have to create the narration. That is the hardest part for me. I don't even like that part. but it's necessary in the YouTube video. If you're not talking, like if there's no audio, like what is it? It's not even a video. It's like sound only. That's like the films that came out around 1900, right? 1900 to 1915 or 20 when sounds was introduced, right? Those things are pretty boring. I can't do that. I have to create the narration. So let me put that together and get the video done, and I'll drop those pretty soon. Until then, take care, guys, and I'll see you soon. Bye.